Hi everyone. In this video, we are going to discuss about a coding challenge called sum pairs. Let us first understand the problem statement. Consider an array of integers, both positive and negative. We need to write a code that finds all the pairs of integers whose sum is equal to given a number k. For example, here we have an array of numbers. We can see it has both positive and negative numbers, and a given number k whose value is equal to 10. So the expected output is a pair of numbers. You can see here there are like four pairs. Each pair, if we take the sum of each pair, it becomes equal to 10. So this is what we need to achieve, right? So a naive approach to solve this problem is we can pick up each element, which we can call it as a of I from the array, and perform k minus a of I, and we get a number, right? And that number we compare it with each other element, which we can call it as a of j in the array, and if it equals, then we can add it to the list of the resultant pairs, and we repeat the same for remaining elements in the array. But this approach has a time complexity of big O of n square, as we are actually picking up each element and comparing it with the other elements in the array, right? So do we have any better approach? Yes, we do have a better approach. Let's see the better approach now. So first we are going to sort the array, given array, using the Java built-in method arrays.sort, which has a runtime of big O of n log n. You can see the sorted array here for the given array, and then we'll take two pointers. One pointer starts from the index 0, so we call that as a left pointer, which is denoted as L, and the other pointer starts from the last index in the array, so that is the length of the array minus 1th index, which we call it as right pointer, which will denote it with R. And then what we are going to do here is we are going to uh, find the sum of the element at index L and R, and if it is equal to k, then we have a solution. So we can increment the L position and decrement the R position, right? So if what if like the sum is less than k? So in that case we increment only L and keep R in place. So you can see this example here, right? Let's take this example. Minus 4 plus 15 is 11, right? So in our case, k was 10, right? So is 11 equal to 10? No, right? So we have to see the next step. Is 11 less than 10? No, right? So let's see the next step. Is 11 greater than 10? That's right. So we need to decrement R and keep L in place. So L should be unchanged. Let's do that now. So R is decremented now, and we need to repeat these steps 3 to 5 until L reaches R. So we can do that now. So minus 4 plus 13 is 9, right? So is 9 equal to k? That is 9 equal to 10? No, right? So next step, 9 less than 10? That's correct. So we need to increment L this time and keep R in place. So you can see it here. We incremented L here. Now again we will repeat the step 3. So minus 3 plus 13, 10. 10 equal to 10. So we have a resultant pair now. So we will just add this to our list of resultant pairs and proceed the steps 3 to 5 until L reaches R. So this is the approach we are going to follow now. And with this approach, so this approach has a time complexity of big O of n, as we are getting the solution in one traversal. So we are traversing the entire array once and we are able to achieve the solution. So let's see this now in terms of code. Here we have a method called pairs, so which takes the array integer and the sum, given sum, right, k, as parameters, and it should return the list of strings which are the actual pairs, the expected output, right? So let's have the array, given array. So I'm hard coding it, whatever we have seen in the example. And the first step, what we'll do is we'll check if the given array, if it is empty, if it is null, and if the number of elements in the array is 1. So in that case we don't need to actually do any we don't get the pairs, right? We don't get the expected output, right? There is no possibility. So in that case, we'll just return the empty list. What if the array has more than one element, right? In that case, the first step, whatever we have seen in the algorithm is we wanted to sort the array. So we'll just sort the array. M is our array. And then we'll start having the pointers. L is one pointer and R is another pointer, which should actually, right pointer should point to the last index, that is array length minus 1. And then we'll start the loop. And this loop should actually run till L reaches R, L less than R, right? And the first thing what we wanted to do is we wanted to take the sum of the elements which at Lth index and R index. Now we have the sum. So this sum we'll use and compare it with the expected K. This is the given number K, right? So if it is equal to K, then we'll add it to the list. So let's create a variable. Let's create an object list of strings. I'll name it as result, and we'll instantiate it to the array list, right? So we have a result now, which actually is a list which can collect the list of strings. So let's add. We have a pair now, matching pair. So what we'll do is we'll just add this pair at L. So we'll just have a comma. This is for for better visibility of the pairs. And then what we wanted to do, we wanted to increment L and decrement right pointer, right? What if this is not the case? Like else if sum is less than K, then what we wanted to do, we wanted to increment left pointer. And what if sum is greater than K? In that case, we'll just decrement the right pointer. This is what we have seen in the algorithm, right? That's all. Once we are done with if L reaches R, that is if L is greater than or equal to R, then we come out and return the list of strings, the result. Now let's call this method pairs in main method. And we need to pass array and the sum, right? K value, we are passing it as 10, the same whichever we have seen in the example. And finally, okay, this actually returns list of strings, right? So we'll capture that into list of strings. So let's name it as list of pairs, and we'll output that on the console. Let us execute the program. Okay, we didn't actually have the second number here. So M of R, right? First element, comma, second element, and close the brace, right? Now we can see the resultant pairs here. So if we take any pair here and try to find the sum of these two numbers, it will be equal to 10. So these are the numbers which were picked from the sorted array, from the given array. So this is how we can actually find the sum pairs from the given array using the and which has the time complexity of big O of n, which we can call it as a better or optimized solution. That's all for this video. Thanks for watching.